Good morning, guys. Today we're going to be talking about Chapter 2, the basic elements of C++. In this chapter, we will talk about how to write C++ code. So after all these chapters, we have the concept of how to design code and the importance of designing code. But in Chapter 2 and from now on, we're going to be writing a lot of code. So in this particular chapter, I'd like to show you and talk about how do we use Visual Studio and how do we make our life a little bit easier going through every single one of the chapters. So we talked about different kind of data types, and you guys did an exercise on assigning values to variables and data types. But we haven't really looked into what a variable is and what a different data type is in great detail. So we're going to be looking at those. And how do we assign values? And how do we output value onto the terminal or onto the screen? We need to look at how to debug errors, and that's going to be one of the major concepts that's not really covered in very much in detail in the book, but I'd like to talk about that and the importance of debugging. And basically, we're just going to learn how to write C++ code. But before you write C++ code, you need to run somebody else's code. So hopefully you've seen that in the chapter you have a lot of different examples, right? Like this example, when the author gives you example code, an explanation for that example code, you want to make sure that you know how to run that example code. So that's what we're going to be talking about. Okay? So we still have to talk about some of the terminology, some of the definitions. So you have computer program, which is a sequence of statements whose objective is to accomplish a task. So when we're talking about a computer program, that computer program is really, when you look at it from the flowchart point of view, right? We have, let's say, the starting point, right? And then we have the end point for our flowchart. So a sequence of statements is basically what comes right here. So this is where you write your code. Okay? And then we have the start, and then we have the stop for our code. Okay, so that was the kind of like a flowchart, the basic syntax, and here we can also say this is my A block. So within the A block I have a lot of sequential code, and that's what a program is. Okay, so programming is not just coding, it's not just about the code, but really about looking at the design of the code. How do you even, by the time you start coding, you already have to have design, and that's what we call programming. So programming is the process of planning and creating a program. So planning is what we covered in previous chapters. And that's what you would do when you are cooking, right? I mean, you don't just come up with some kind of a idea that you're going to be cooking chicken cacciatore tonight, and you have no clue about the ingredients or how to actually cook it. You're going to start cooking that dinner, and you're probably going to mess it up because you don't have a proper plan. You don't really understand what you're trying to do. So if you only focus on coding, you're a coder. If you understand the process of planning, coding, and testing at the end, then you become a programmer. So when you read the book and you go through every single source code, okay, you do not have to write this, but it would be nice to actually see this code running. So in order to do that, we really need to open the Visual Studio at the same time as you are reading the book. If you just read the book and you don't have Visual Studio or whatever compiler you chose, then you're really not going to learn much. So when you see the code within the chapter, okay, let me share my screen out so you guys can see my screen. Okay, so if you go under content, within eCampus, okay, here's where you have the data files. Okay, so you can actually download these data files. Okay, so you click on the data files, let it download. Okay, and when you download the data files, make sure that you're going to put them in a proper place. So don't just double click on them. Okay, you don't want to use them in the zip file. In the title bar, if you still see the file name as .zip, the files are not extracted yet. Okay, so make sure that you're going to select all of them, maybe copy them to a location. Okay, and I would say create a folder and write, let's say, CUSC 1436 or 1415, whichever course you're taking. 1436. Within 1436, I have another folder, and I'm going to call that maybe source codes. Okay, and I'm going to extract all these source code files into this folder. So you can see that in chapter 2 we start talking about actual code and not just the design. So at this point you guys are more comfortable with the design aspect. So now we're looking at source code. So when you look into chapter 2 source code, you can see that you have a lot of source code that is discussed in that chapter, and you are not done with the chapter unless you run all this code. Okay, so make sure that you run all this code. So then you look at the presentation, okay, and you can see that there is a code. And because we have that code right here, I'd like to see how that works. And I'd like to know, what do you mean by declaring variables? What do you mean by output? What do you mean by initializing variables? Or how does this arithmetic operation works? What do you mean by return value? None of that makes sense to me. Well, we go back to our So we go back to our Visual Studio, right? So we have Visual Studio running, and if you don't know how to create a project, make sure that you go into assignment 1, and maybe you have to refresh your memory on how to create a project. What we created in assignment 1, and we just copied the source code. So we didn't really know what we were doing at that point. Now in this chapter we're exploring what we need to do. So we create a new project. Okay. We make sure it's a Visual Studio and a Visual C++ console application, and then put it in a folder that you can remember, right? So I have the CUSC 1436, and maybe I'm going to call this Learn. So I'm not doing the assignment. I'm not doing any kind of projects. I'm just going to learn about chapter 2, and that's my goal. So I'm creating a folder, and usually later on we're going to talk about what a driver is. But we're just going to call it driver, and the driver is going to be this project that we use for all chapters. So one single project for all chapters. So now I say OK. We go next. We make sure that we have empty project, and we say finish. So now we have a project. So in this project, we need to have source code. We need to have source files. And in order to use the source files, or where do we get those source files from? Now this project is just to learn. I need to learn about chapter 2. So when I look at the source files, in assignment 1, we added a new item. We created our code. But right now I just want to learn. So I want to add an existing item. And if I put it in the proper place, it's easy for me to find where my source code is, because I put it under Computer Science CUSC 1436, under Source Codes, Chapter 2, and I want to see what's in example 2-1. So I add that source code to my project. You should have no other source code but one single source code, okay? You cannot add all of them at once. Don't do that, because C++ requires that you have only one main method in all the source code files. Now in our case, all the source code files have a main method. So you're going to be troubleshooting for a long time to figure out what's wrong. So once the source files has only one single source file in it. And this is talking about example 2-1. If you look at the presentation, right? If you look at the presentation, you can see that this code is exactly the same code that comes with your source code 2-1. Okay? So if the author explains something, explains a code, and you have exercise 2-1, that means you have the source code for that within the source folder. You don't have to modify it or write it yourself. You just load up whatever the author gives you or gave you. Okay. So now we have this code, and you can see that there is a author provided header, right? I provided your header. So when we go under the syllabus tab, if this would be an assignment, then you would just basically use this header, right? Select it, copy it, and then paste it. So this is our header, and then you're just gonna make the proper changes to adjust it to the course that you are taking. But in this chapter, make sure that you go through the PowerPoint presentations, and in the PowerPoint presentations, you're gonna see that this is what we call a preprocessor. Okay, so now this preprocessor starts with a hash mark and starts or continues on with the keyword called include. So include will include a library. And this library, if I look at this library, look inside that library, you can see that here's our cin and cout. Okay, so we have predefined identifiers, predefined variables that are created for us to use. So really, when you're talking about the preprocessor, we need that for cin, cout, and endl, right? So we're gonna need that endl. We need the cout, okay? And in this particular case, we don't have cin, but these are all predefined variables. That's why we need to have the preprocessor. And then you look at this using namespace. Now, what is that namespace? Now, if I comment this out, remember the single line comment is just //. Okay. If I have a multi-line comment, I start with a /*, and I close the comment block with */. Okay. So now here, if I create a new line, see, the // only applicable to that one single line. So now these two words are in different line and they are not comments anymore. But if I add in more lines of code in here, you can see they still stay as comment. They still stay as green color. Okay. So it's your choice what kind of a commentation that you're going to use. Okay. But there are two different kinds. The IDE is very useful because with the IDE we can see the color changes, and you can see that anything that's green is not going to be considered at compile time. So it's not going to have to follow a C++ syntax. It can be any kind of a word, any kind of a phrase, or any language that you want to type in. This is for you and for other programmers to know what the program is doing. So commentation is important. So what does this namespace mean? So if you look at it, as soon as we commented out the using namespace std, you can see that we see these squiggly lines. If you look at it, the error message, make sure that you learn it by looking at the error messages. If you look at the error message, it says identifier cout is undefined. Okay. Now let's see what if I comment out length. See, now length has a squiggly line, and you can see that it has the same error message. Identifier length is undefined. Now what is an identifier? An identifier can be a variable, a function, or a constant, right? So you can see that cout is a variable just like length, but cout is predefined for us. Okay? Length is a variable that we have decided or declared. So now as soon as I declare the variable length, the squiggly line goes away so that we don't have any more error. So how do we fix this squiggly line under cout and endl? Well, they are defined in IOString. But if you look at it, okay, if you have, let's say, two rooms. Oops. Let's see. Yeah, so we have two rooms. One room and two rooms. Okay? And let's say that this room is called room 1. And then we have another room called room 2. Now within each room, let's say we have an instructor, okay? And let's say this room also has an instructor. So how do we find one instructor versus the other? They all call the same. So the instructor is the identifier, and the room is where the instructor lives. The rooms are unique, but the instructors are exactly the same. So how do we find this? So here, if I want to refer to the instructor in room number 1, it says room 1 : this is what we're going to call a scope resolution operator. So later on we're going to learn about all this. Okay? And we're going to say instructor. Okay? Come on. Instructor. Now that specifies in room number 1 the instructor. If I need to look at the other room, okay, the other instructor, I need to say room 2 : and I have the instructor in there. Okay. So if you look at our code right here, okay, cout and endl is defined for us, but where are they? Well, they are in room std : okay, and endl is in std : Okay? That is what we call a namespace. So namespace, think about it as a room. Now when we use cout, we would have to say std : in front of every single one of the instance of cout. Okay. So we would have to write std : in front of every single one of them, and then eventually all the error goes away. It's like, whew, that's a lot of typing, a lot of repetitive typing. So I really don't want to type all that. But at the same time, I like to compile it, so I don't need all these error messages neither. So what can I do? How can I get rid of globally of these error messages? Well, here we can say, when I say a variable, check in the room called std, and see if there is going to be a variable, an identifier defined within std. So if you use std : it's not a problem. You can see that's not a problem. But if you don't use it, we don't get an error message anymore. So basically we're using the namespace so we can get rid of all this std : and we don't need to type those anymore. The variable is going to be located within std. So let's say I want to write a comment to this line, right? So to avoid using std : in front of every cin, cout, and endl, right? So it's just a comment, just to remind me why am I using this statement right here within my code, right? And then we have main, and main is a function. So this is the start of function main. Now when it comes to functions, I like to look at the functions as kind of like a watering can, right? So you have a watering can, and here's the handle. See? Beautiful drawing. Okay, so this watering can is called main. That's the name of the can, right? That's to say, that is the name of my function. Now when we have a function, okay, hang on, should be able to draw an arrow. There you go. Oops. Back to the drawing board. Okay, so we have the function main, and the function main is considered like a watering can. And the previous one was much better. So this watering can is called main. When we talk about the function has something that we send to the function. We're filling up the actual watering can with water, right? With some kind of contents. So these are our statements inside the functions. Okay, it's kind of like these statements right here. All these statements are inside the watering can, and then something comes out of the watering can. Okay, now what comes out is going to be defined by whatever is in front of the function, and what goes in is going to be defined by whatever is in between the parentheses. So with the parentheses, that's where we have something coming in, and with the data type in front of the function, and this is our function name, the data type in front of it tells us what comes out of it. That's the reason why we were sending return 0, right? So the return 0 was the value, which is in this case 0, was coming out of the watering can. Okay. So what went into the watering can? The parentheses is empty. So that means, as far as we are concerned, this is an empty parameter list. So nothing went inside the can. We are just running the statements and 0 comes out of it. Okay. So this is my function main. No parameter list, empty parentheses, right? And integer data type returned. So integer comes out of it. Here's where we looking at data types and how do we declare variables. So this is the declaration, variable declaration. Every single one of these. So we're going to have 4 locations where the locations are referring to memory locations. Remember that we have memory, and this one says double. So double is 2, 4, 5, 6, 7, 8 bytes. Okay, so all this is what a double data type is, right? So a double is really going to be what is it? 2 to the 63rd possible choices, or that's the largest number we can represent with 8. So let's say, what if we would have, let's say, a short, right? Let's say short TTT. Okay, how big is a short? So when you look at the short, whoopsie. So short TTT. So short would be let's do this again. Short TTT. Okay, I'm going to draw the box. Okay, so short would be 2 bytes, right? So the size of it is 2 bytes. And when you look at the 2 bytes, how many bits we have in 2 bytes? In 2 bytes we have 16 bits. So that's going to give us the maximum value that we can store in short is 2 to the 15th, right? So basically the data type tells you how big, how much of a space you set aside for the variable, right? Because right now this variable is somewhere in memory. So we have 0x, let's say 15, okay? The memory address in hex value for this location of the 2 bytes. Now short TTT is pointing to that memory address. And within that memory address we might be just storing 5, the value 5. So in this case, okay, somewhere we must have said TTT equals 5 colon, right? But the space it requires is only 2. In double it would be 8. So that's the declaration. Now we have in output statement, right? So we have, oops, my caps lock is on. Output statement, right? That actually terminates at the semicolon. Okay, so all this is the output statement. And here you can see that we do some kind of calculations and assignments, right? So this is the assignment. We are assigning values, in this case values, and here is the return or the result of a arithmetic calculation. But we are using the assignment operator with that expression. Okay, so we declare variable and then we have to assign them values, and then later on we also have output. Then we have the return value that we return to the operating system. So if you followed assignment 1 all the way and you did this arrow level, right, you could see that when you changed the source code to return 2011 in this case, if you typed in echo error level, then you would get 2011, right? So you are running the application, you run the application here, and then when you look at the error level is what the operating system received from your application after it ran. So that's why we did that particular exercise. Okay. So this is the return value, okay? And now this bracket is the end of main. So this is my end of main function, right? Make sure that you have the open bracket and then the close bracket. Okay. So that way you can comment the brackets, and you're never going to forget to close a bracket. So every open bracket needs to be closed. Every open parentheses needs to be closed. Okay, so write down not much comment, but just enough comments so a code can make sense to you. So at this point, how do we run this? Well, I need to see how does this declaration work. So I want to put a breakpoint in my code. Just click in front of the line of code in that little gray bar, this gray area. Then I need to look at what happens after I run this line of code, which is cout. Then I need to see what happens, and maybe we want to see that one line at a time. Okay, what happens when we assign values to variables that we have declared before? And then I want to see the output. So what if we need to write a flowchart for this, right? What would that look like? So you can look at it as the start and the end position of the program is the start and end position of our flowchart, right? So we have the start position. Then what do? We declare variables. Declaration is just a rectangle, right? After the rectangle, what do we have? We have parallelogram, right? So I need to somehow draw a parallelogram. Okay. So that parallelogram is containing this right here, which is the printout statement that we have. And then comes the calculation, the assignment. Now the assignment also just going to be a rectangle, right? We're not asking the user for anything, so we're just going to use the rectangle. So the program continues on. And after we're done with the assignments, then we're going to print out the results. So those results are, again, in parallelogram. And then we close down our program. So that would be the flow chart for this particular program right here. So calculations come in here. Multiple lines can be in one box, and then multiple lines of output into the parallelogram. And this return value shows where the stopping of the program is. Okay, and you can see that the name of the function would be the start of this flow chart. Okay, so let's run this, right? So we have the breakpoints. So what happens when we run when we have the breakpoints? So we save the changes and then start running the program. Make sure that you only have one CPP in your source files. It might take a while for first time to have the code running. But it will pop up with a terminal window. And it's gonna get there eventually. There we go. Okay, so what is the important thing right here? The important thing will be that you're gonna click on locals, okay, to see all your local variables. And here you can see that this is what we call a garbage value. Okay, let me just change these. Okay, let me just stop this right now, and let me change this to float. Okay. Let me change this to int. That can be double, and let me change this to short. Okay. So we have different kind of data types. So when I run this code, right, we stopped the code. You see the little yellow triangle, little arrowhead. The little arrowhead shows you that where you stop the code. So we ran these 4 lines of code, and right now we're about to run this. You can see there's nothing in the terminal window. So we're not there yet. We haven't executed that statement yet. So what's in our variables? If you look at down here in the bottom, okay, you can see that area, width, perimeter, and length, those are different data types. And the different data types have different, what we call, garbage value. Right? So these are the garbage values. All these negative values are the garbage values when you declared a variable. So the variable has nothing specific in it at this point stored by the user. So the language puts in garbage value, initializes it to garbage value at declaration time. So later on we talk about that it can be very dangerous. Okay, so we need to initialize those values. So we can just click on continue. When we clicked on continue, you can see that the actual text, the literal text, what we type in between the double quotations is displayed, but not the comment. You see the comment, the green, was ignored because we started the comment with the double /. And length equals 6 is not assigned yet because we are not executing that code yet. Okay. So you can see that the length still has garbage value because we haven't executed this line yet. But we have executed this much. So we declared 4 variables and we printed out to the screen a text, a literal text. Then we continue on, and now you can see that length is actually assigned 6. Continue on, width is 4. Continue on. Now perimeter is calculated by adding length plus the width and multiplying it by 2. So that is an arithmetic expression. The result of the arithmetic expression was assigned to the memory location where perimeter is pointing to, and 20 was stored there. Then we continue on. We changed area from garbage value to the actual value that we have calculated by multiplying length times width. And the code was continuing on by displaying the literals, and then after the literal text we displayed the value of the variable. So length equals 6 because length content is 6. And now we are stopping at the return. When we continue on, the terminal disappears. Now let me just take these breakpoints off of here and let's just compile it. Do you see how the terminal window just pops up and just gone? Okay. So what you want to do is you want to put a breakpoint in front of return, and then the terminal window stays open until you continue and you stop the code from running. Now the other way to do this, and I would recommend that you do that in this class, is to type in system. See, system is the watering can, right? It's a function. It's the name of the function, the name of the watering can. And in this case, we do have to send something to this function, and we're going to send pause. Let's see what happens now. So I don't have a breakpoint in front of any of my lines, and I run the code, and now it displays press any key to continue. It will stay open until I press the enter key, and then you can see that my application stopped running. Now what is this pause business? If I look at my terminal, okay, and C and D is my command prompt. Okay, so if I just type in pause, you can see it's the same message. So what we're doing is we're calling this utility from Windows. It's called pause. So you can see the system, which is basically the operating system. Operating system run the command called pause, and that pause pauses the screen, so the terminal window stays open until you press enter. So you can do it either way, either with the pause or put the breakpoint in front of the return. That way the terminal will stay open and you can see the output. Okay, so two different ways to run it. Okay, so at this point maybe I'm done with this section of the chapter. So I don't want this code anymore, but I'm coming up with a different code within the chapter. So what you do is you remove this. Okay, so I just remove the source code, right click, add existing item, and maybe in the chapter I get to example 2_3. I add that to the exact same project. I double click on it and I can look at it and see what this section of the chapter tries to teach me. So you're reading the chapter, you're reading the author explanation, what this code is, or what are these expressions, what are these operators, how do they work, okay? But make sure that you put in your own comments, okay? So this is for your CN, Cout, ENDL, right? Why do we need this? To avoid using std : with Cout, Cin, and ENDL, right? Then I put in that this is the start of main, and this is my end of main. Here's my return value. It's pretty much always the same. And now we need to learn about the actual code, okay, and what it does. So again, we can stop this a few places, or I would recommend that you, until you get comfortable, stop it at every single line of code, run your code, and see what's going to display on the screen. So 2 plus 5 is 7. 2 plus 5 equals 2 is a literal, and then you have the actual expression. So 13 plus 89 is 102. 13 plus 89 equals 2 is between quotation marks. So that's going to be displayed on the screen as a literal string. And afterwards, we are adding 2 values to that literal string printout. And we are printing out the actual result of that operation. So you can play with this and play with the code itself. Now what I would recommend is most people have problem understanding what the modular operator is, or some people call it the remainder operator. Okay? So how does that work? So we can actually look at it in a nicer fashion. I would recommend that we change this to the same division like we are using in the modular operation, just so you can see how that works. Okay, so what happens if we divide 34 by 5? And what happens when we divide 14 by 7? And what do you mean by the strange modular operator? How does that work? So if we don't know how that works, we can stop the code, all right? And it might make more sense how that actually works if we run it one line at a time. So you can see that 5 divided by 2, oops, we also need to change the literal, right? Sorry about that. So let me change that too, because we're not displaying the previous values. Okay, so this is 14 mod 7. Okay, so now we're going to see the same value as the string explains it. Okay, so what is 34 divided by 5? Okay, so 6 times 5 is 30. So that means 34 divided by 5 is 6. Now why is that 6 and not fractional? Because we are dividing 2 integers. This is called the integer division. If we divide an integer by an integer, the result going to be an integer. Okay, let me show you this. If I would do something like .0, and I would do the same thing, right? .0. This is just a literal, so it doesn't really matter. But I try to divide 34 by 5.0. Now you can see that it is 6.8, right? Because it is what we call a mixed expression, an integer divided by a floating point value. So, but that's not what we want to do right now, okay? So let's run it as 34 divided by 5. So 34 divided by 5 is 6 whole times. And then we continue on. So 14 divided by 7 is 7 goes into 14 2 times, 2 whole times. So then what do we mean by the modular operator? So we continue on, and you can see that 34 mod 5 means what? 34 divided by 5 is 6. But 6 times 5 is 30. What is the remainder? Remainder is 4, right? So the mod operation, modular operator, shows you the remainder of the division. So this is kind of like the division, but instead of looking at how many times a value goes into another value, right, what we're looking at is what is the remainder after the division. And if we continue on, now how many times 7 go into 14? 7 go into 14 2 times, and the remainder is 0. So if we say 14 mod 7, then the remainder is going to show as the result is going to be 0. So you can see without writing code, you can play these kind of arithmetics, and you can understand every single line of code, and you can make minor changes and learn even more about the code. Okay? So again, I don't need this. I'm done with this section of the book or the chapter. I remove it, and I'm going to add another item. Maybe I'm at the next section. So in the chapter, you see an example 2-4, and then you start looking at it and see how does that work. Okay? And now you have a different example. Now, if I just run this, see, I have no clue what the output was because it just popped up and went away. How do we stop it? We either put in the breakpoint right before the return, which is the last statement. And now you can see right here, there is the inches. How many inches? The inches are 100. See, here's the variable. You can see that there is 100 stored into inches, where inches is an integer data type. And now you have 100 divided by 12. Right? So, so how many times does 12 go into 100? 8 times. So 8 times 12 is 96. Right? So 8 times 12 is 96. Then what was the remainder? 96 plus 4 is 100. So if we do inches, which is 100 mod 12, then the remainder is showing up. So this is how you would use in programming the modular operator. You need to look at, in this case, you have 100 inches. Now 100 inches is how many feet, and what is the remainder inches? So it is 8 feet and 4 inches. Okay? You need to run this, and you need to play with this code, and if anything doesn't make sense, then you need to bring it either to the live sessions, or I would prefer that you asking question on discussion board so everybody can see your questions and they can comment if they have any kind of a comment, or if they can help you. But this is what I want you to do from now on with every single chapter, that you remove and then you add the source code that came with your book. So if you start on chapter 3, then you go to the chapter 3 section, and then you talk about, you run all this code, and that's how you learn each one of the chapters. Okay? So let's see. Okay. So you see, that's how this code comes in. But the code is not there that you need to remember it or write it down or waste too much time on the actual syntax. But what I want you to do is actually run the code. Keep running the code and learn from the code based on the running the code. Okay? The author also tells you the sample run. So when he gives you the source code, it also gives you a sample run. So sample input, and then it will show you what the output is supposed to be. If it's not, then you need to find out why it's not. So you can bring questions about your code. Why do you think you don't get the same results as the author does? Okay? So this is the chapter, like I just showed you, right? One line at a time. The the book author tells you every single line and what they mean. Okay, the variable declarations, and then you assign the assignment statements. Okay, and you can verify all this by running the code in Visual Studio. Okay, so you go through one line at a time and you understand every single section, every single statement, every single line. And as you realize something new, make sure that you put in your own comment. Okay, comment your code instead of writing it down on a piece of paper or a separate notebook like you would do in other classes. Here, what I want you to do is type in your comments. Okay, so comment the code that you are actually running. So it's talking about the whole variable naming convention, right? So really, when you have area is the name of the variable, which can be changed. We can change it at runtime, right? So we can have something like, let's say 2.0 over here. And when you look at it, 2.0 is really, maybe this is 5. Okay, or do 0x5, right? Maybe that's going to be the actual address. Okay, 0x5. So what that means is that area is pointing to that address, and the address is storing the value 2.0. But we can come back later on, all right? And we can change the value, and maybe we're going to change it to 12, right? The name of the variable does not change. It's always stay the same. When the program is running, the memory stays the same. So the area is always going to be pointing to 0.5. How did we locate 0.5? Well, when we declared the variable called area, the system find the location. Now, how big of a location it needed to find? It depended on what is the data type of the area. Area data type was double, so that means each one of these boxes represent 8 bytes. Now, if we stop the code and then we run it the next time, it might be pointing to a different memory address, but at runtime it doesn't change. The address stays the same. The value can be changed, and that's why we call it a variable. Okay. So more definitions. So a function in C++ is a subprogram, a collection of statements when executed accomplishes something. Either may be predefined or standard. And that's where I showed you the whole concept of a watering can. So think about the watering can. A function can receive parameters and return some value after it's doing some calculations. Syntax is the rule. So we need to follow a particular syntax. So we need to terminate each line of statement with a semicolon. That is one of the syntax rules in C++. Now, semantic rule determines the meaning of the instructions. Right? So just because something is syntactically correct, the syntax correctness does not mean that the meaning of the sentence, the meaning of the statements is also proper. Right? So so you need to look at the meaning. So if I say, let's say, my book went to the store yesterday, grammatically it's correct, but meaning-wise it doesn't really mean anything, because books are not living entities and they don't go anywhere unless somebody takes them. So syntax-wise it's correct, but semantically it's incorrect. So if you're saying that something is falling and that something is pulled by the gravity, and the gravity is 10 meters per second, right? Then the speed is increasing. So when you have the okay, we lost the video or the connection for a little bit, so there's a little interruption in this video recording. Anyway, so in this chapter, make sure that you also focus on the definitions. Okay, so the syntax rule is going to be something that can be enforced by the compiler. Okay, so the compiler can see if you're following the proper rules. Now the semantic rules, right? If we are adding instead of subtracting, or subtracting instead of adding, now those semantic rules cannot be checked by the compiler. So in that case, what we need to look at is, okay, so how do we code? Our coding should be something like this, right? So because we design the code, we spend some time on designing the code. It's going to take longer than actually coding. And at the end, after we're done coding, we're going to test it. Test if the code actually works. So when we're designing, the design is relying on flowcharts, right? Flowcharts and pseudocode. When we code and we make mistakes at codes, what we're going to be using semantic rules, and within the semantic rules, the compiler will catch our errors. So even if we make a mistake, it's going to be easy to see where we made a mistake. We're going to have the squiggly lines. The compiler will catch it. The problem is, when we're going to have semantic rules, then we have the semantic problems. The semantic problems we can only catch when we actually testing the code, right? So you're supposed to be falling. As you fall, you go faster and faster and faster, but you find out that you're actually going slower and slower. So something is not right. The logic is not right. That kind of an error can be only be tested or located by testing and by selecting the proper values. Remember your assignment when you had to figure out if testing the code with students assigned to different courses, is that a proper testing list? And you figured out that that list wasn't proper to test students that were assigned to art class because the input value, the input list did not have any students in it that was assigned to the art class. So if you're trying to test if you are really going faster as you're falling, and you don't put in the right values, you don't test it with the right values, you're never going to figure out if your code is properly implemented or not. Okay, so that's what this is talking about. That's what this section of the chapter is talking about, and that's why it's going to be very important for you to understand different terminologies and make sure that you can define and you thoroughly understand what these terminologies mean. So then the programming language is a set of rules, symbols, and special words. Right? So we have rules. Those are the syntax rules. We have symbols, and then we have special words with every single programming language that you ever gonna learn, right? So we have the comments. Comments are single line or multi-line comments. Again, type it into the Visual Studio, type it into one of the sample code, and make sure you understand how that works. What do you mean by single line and multi-line comments? Okay. special symbols, right? You have the special symbols, which can be either Boolean operators or terminating punctuation marks, right? Semicolons, how we punctuate the end of sentences, okay? And then you can have arithmetic operators like multiplication and division, or the modular operator. Reserved words or keywords. Keywords are the ones that look like they're blue in Visual Studio. So it's easy to spot keywords. What does the keyword mean? Keyword means that you cannot use it as your own variable. So you cannot have a variable called int, of data type int. Int is reserved for integer data type. You can do capital INT, right, because C++ is case sensitive, but you don't want to do that because when we declare variables, we're using the camel casing, and we don't start with a capital letter. So anyway, keywords, you cannot use it as identifiers. So what are the identifiers? Identifiers, the name of something that appears in a program, consists of letters, digits, and underscore character. It must begin with a letter or underscore. So either letter or underscore, but by definition or by convention, okay, we don't ever use, okay, we don't really use the underscore to start our variables with. We leave that to those who maintain the compilers, okay? So that leaves us that we're going to start variables with characters, and we use a camel casing as a standard, naming standard. So C++ is case sensitive, so make sure that you understand that. And usually when we're talking about, let's say, all capital numbers or lowercase number, all capital means it is a constant. Constant means you cannot change it at runtime. All lowercase means it is a variable, right? So it's a different, even the casing tell us a lot. And this is not going to be enforced. This is just a convention what we use. Now here are the predefined identifiers. Remember the COUT and CIN? Those are going to be in your IO stream libraries. They're going to be predefined for us. But as far as the color is concerned, remember those are COUT, CIN are black characters, just like any other identifier. It just happens to be predefined for us. We don't have to define it ourselves. Now where do they reside at? They all going to be in STD. So why is it that we don't have to say STD : in front of it? Because we're using the statement using namespace STD : okay. Unlike reserved words, predefined identifiers may be redefined, but it is not a good idea. So try not to call anything COUT or CIN. Leave the COUT for output and CIN for input. Don't redefine them, okay? So then you have these exercises. Again, you need to go to the chapter and you do every single thing. I cannot really say that any single paragraph, any single example is irrelevant in this chapter or any chapters. Make sure that you use them to your advantage, right? So go through this. And why is this? The first one is illegal because we're using a space. Space is not a legal character, right? Exclamation point is not a legal character. Plus sign is not a legal character. The rule says we cannot start the identifier with a number. So that's why it's bad. Okay? Okay. So here we have our convention, right? The convention is we have two words and the two words run together. Okay? Second word, and then we have the first word. So the first word starts with a lowercase. The second word starts with an uppercase, and that's what we call camel casing. Okay, so I'll see you guys next time. make sure that you understand after we covered the chapter 2, you're going to have to take exam, a test. So make sure that you keep up with the coursework, keep up with the syllabus, okay, and preferably read ahead of time. So that way you can stay ahead of schedule and you don't have to worry about taking the exam. Okay? See you guys next time.